Jam Pass question 2002. Question number 6. A weight and axle is used to raise a load of 500 Newton by the application of an effort of 250 Newton. If the radii of the weight and axle are 0.4 cm and 0.1 cm respectively, the efficiency of the machine is. Very interesting question. Today our question is centered on machine. Before you can do justice to the question, first of all, bring out your parameters. Okay. Solution. We are given load 500 Newton. We are given efforts 250 Newton. We have radii. Weight and axle is one of the kinds of machine. Weight and axle involves a bigger wheel and a smaller axle. It's a machine that is common in our neighborhood that is used in lifting objects. You apply your effort on the bigger wheel so that when you succeed in making one rotation in the bigger wheel, it will give you multiple turns or multiple rotations in the smaller wheel. That's the wisdom of that machine. That's the science behind the machine. You put your effort on the bigger wheel, then the load on the smaller wheel. Succeed in making just one rotation of the bigger wheel, you have multiple rotations in the smaller wheel. Therefore, each of the wheel will have its own radius. Plural form of radius is radii. Okay, let's take this one as radius of the wheel. The bigger one, we'll be giving it a bigger number, 0.4 cm. Then radius of the smaller wheel, the axle, we'll be taking a smaller number, 0.1 cm. Okay? Then efficiency is unknown. We're looking for efficiency. Then we can solve. A machine will have a formula for finding efficiency. The formula says efficiency is equal to MA over VR times 100 all over 1. A very simple formula. MA stands for mechanical advantage. Every machine has advantage over man. Mechanical advantage. That's why it's a machine. Then VR stands for velocity ratio. So we'll take it gently. We don't know the mechanical advantage. We don't know the VR of this particular machine called weight and axle. So this is the center of concentration. A machine by name weight and axle. So to get mechanical advantage is the same for all machines. But VR will differ with a particular machine. So let's get VR. To find VR, forgive me. To find MA, mechanical advantage, we apply the formula load all over effort. It's also called the force ratio because load and effort are forces. This is what you apply, effort. This is what comes out of what you want to carry, load. Okay, let's find out MA. Observe our load, 500. Observe our effort, 250. Therefore, our mechanical advantage becomes ratio of 500 to 250. That will give us 2. It will have no units. This is Newton, that is Newton, they will cancel. So our MA is just 2. We've got MA, remaining VR. Then to get VR, VR of a particular machine is distance moved by effort divided by distance moved by load. In this machine called wheel and axle, when you move the wheel, it goes round a circle. It makes circumference of a circle. Recall, VR is distance moved by effort over distance moved by load. So let's link this idea to the machine itself. Recall MA is 2. So I can wipe this. Then VR is equal to distance moved by effort here is a circle. The wheel represents a circle. When you turn it, you'll be having circumference of a circle, 2 pi capital R. Because the effort is put on the bigger wheel. So we'll go for bigger radius divided by distance moved by load. The smaller axle bears the load. It will also be 2 pi small r. Because that takes a smaller circumference. 2 pi are the same, they will cancel. So VR of weight and axle is capital R over small r. Then continue. Our capital R is 0.4. Our small r is 0.1. Find the ratio. You'll be having 4. It also have no units. cm, we'll cancel cm. So our VR here, x, 4 without units, because units will cancel. This velocity ratio or distance ratio, they will cancel out. Then we've gotten our VR to be 4. Then nothing is left out. Then to solve the equation, then we'll now push ahead. Efficiency is equal to MA is 2, VR is 4 times 100 all over 1. This is the same as 1 over 2. So half of 100 efficiency becomes 50%. So the way an axle is 50% efficient. 50% efficient. Do you think it's a very nice machine? Do you think it's a nice machine? A perfect machine is 100% efficient. So our machine is half efficient as a perfect machine. Does that go well with you? Is it a nice machine? That's a question for you to answer on your own. Please stay tuned as we push ahead.